usually doesn't save the video. I don't know what it is. So multiple choice. For alternate exterior, both outside the lines intersected by the transversal, right? So these are the lines that are intersected by the transversal, and they're on opposite side of the transversal. So C is the one you were supposed to have picked there. 2, to be honest, but I think it just made sense to go with all of the above. But it should have said if a transversal intersects two lines that are parallel, right, then all of the above would be true. So there it is. Vertically opposite angles are always congruent, right? Like these two will always be congruent, or these two. Parallelogram can be a regular polygon. That is true, because a square is also a parallelogram, because it has two sides that are parallel to each other, so it's a parallelogram, so that's true. A triangle with interior angles of 60 is a regular. That is because it's an equilateral triangle, right? If it's 60 all along, it's equilateral, so it's a regular. The number of sides equals the number of central angles. That is also true. So all of them were true there. Here, simply like there are many transversals here, and in each instance, you can justify whether or not what the missing angles are. And for each of them, there's a different reasoning or justification. I think if you got something wrong, it happened right here. SFE is asking for this one. And so that's alternate exterior, right? That's how you would, so it's 28 degrees, not 100 and whatever, 40 or 50, whatever the other angle was. So keep going. And I appreciate, I think everybody told me their storyline. And I think in this one, most of you got this one wrong. Angle C. You did use consecutive interior angle or alternate interior angles. But what you missed is that, yeah, 84 is alternate interior with this whole thing here. So you have to subtract the 49 to get this one in here. So that's the 35. So some of you got that wrong. Other than that, you were doing pretty good. So not much else I can say there. And then this one, I mean, you've seen this one before or something similar to this before. But I used 3-letter notation on this one, so you really had to think where are those angles. And I also made a mistake here, but that's a gift there for you. It wasn't supposed to be given. I was probably trying to ask for this one, and something went wrong in the process. You're welcome. So 27, right? Cab is right here, number 1. So this is 27, alternate interior. Don't worry about the crossing in between. Just go from one parallel line to the other using one transversal. And then corresponding, 147 corresponds to this one here, right? They're corresponding. And then 3, vertically opposite. And I wanted to do a sum of triangle there, but didn't work out. Next time. Go to question 3 here. A lot of you left B, question B blank, but really I had already kind of set it up for you. But it is what it is. And M was supposed to have been right here. I just said omit, right? Avoid confusion. In retrospect, I probably should have just added it. It was easy enough to do, but it is what it is. You all know that this is 2 central angles worth, I'm assuming. But anyways, so I did this one first, Z, I did that first. That's the interior angle, which is 128.57. I did secondly, I figured out Y using this trapezoid. Some of you chose to use the pentagon up here, the isosceles pentagon, to find X and then find Y. Regardless, you would have come up with the same answer. I get 51.43 for this one. And then for x, which is the last one I do, I just take the interior angle, which is 128.57, and subtract y from it to get that. Okay. And then how do you know these two lines are parallel? The CIAs, right? Like this one and this one, right? They add up to 180 degrees. So that's what I was looking for there. And then this one overall was done well. Some of you forgot to divide by 2 at the end. And then there were some variations like K. Some of you found interesting ways of solving K. You need to be careful. So really the interior angle, find this one, find that one, right? Using this pentagon, the trapezoid, find these two and subtract it from the interior angle to get K, which is wedged in between. Continue. Done. This one was done well for the most part. Some of you you subtracted 12 instead of adding, so that was a -1, and you forgot your degrees, so watch out for that. But other than that, the setup, the initial setup, all of you, I think, realized, oh yeah, that adds up to 180, so way to go. Here I had a mixed bag here. Some of you added it up and you got, I don't know, 798 or 698, and so somehow you forgot to add some of them up. But the bottom line is that a heptagon, no matter what, has an interior angle, a sum of 900. So this is the S formula, should be that. If you do a check, it's 898. Right? So it's not reasonable because what should be happening is not what actually happened. Then this one, you know what? I think this one you home run on this one. I think most, if not all of you got this one right, regardless of what method. Maybe something went wrong along the way, but for the most part, I must say you did very well. So go like this. Way to go. Way to go. And then here, for the rens, a lot of you left that one blank. You could have scored partial marks, right? So 15-sided polygon is 156. The triangle is 60. So if you use one of each of those shapes, right, you just subtract that and then you're left with 144. That's need a shape with an interior angle of 144 to complete that tiling arrangement. So you take that and it's basically this question all over again, where you just figure out the number of sides and you couldn't guess. You had to actually do the math, right? Some of you guessed. So yeah, I still take that over nothing, but it wouldn't give you the marks here. So the third shape has to be a decagon or a 10-sided polygon. The renovation, for the most part, I was very happy given that we haven't done it in a while. Some of you made this, like you made this your length or your width, but the ceilings, right, this is the height. It has to be the height. Whether you make the length or the width, one or the other, it doesn't make a difference. But the height has to be done, has to be identified correctly, because you don't paint the floor, so it will matter there. Anyway, so this is how much the surface area is of the entire room with the ceiling. You subtract the windows and billboards and whatnot. This is what's paintable, right? And then you need to multiply it by 2 right away, not later, not anywhere later. It happens right away. You need to figure out, okay, it's the equivalent of basically painting 2 rooms. So it's like 881 square feet. You divide that to get your number of cans, which is 9. 9 times the cost times taxes. This is what I wanted to see there at the end of the day. And of course, that's different if you made a mistake in A, but you don't get penalized again. And then this one, I turned that into 3. I don't know if you noticed that. If I didn't change that to out of 3, maybe do that right now so you know what happened. And so basically you want the area of the floor, and then you want the area of a tile. And there are different ways students did this. It doesn't matter how you did it. It ends up being that one tile is the equivalent of 2.25 square feet. So what I did is 18 inches divided by 12, you're essentially turned that into feet just by going over 12. Okay, so keep that in mind in the future if you want to do that. It's maybe a quicker way. So I go 18 times 18 divided by 12 times 12, which is 144, and that gives you this. Okay. Alternatively, let's do it the way I showed it to you at the beginning. 18 times 18, 18 inches times 18 inches. That gives you something squared inches. What is that? 324. So 324 squared inches, right? And then we would have talked about, how do you turn that into square feet? And you know that 1 foot has 12 inches, and you must square that conversion factor, right? So it's 324 divided by 144 at the end of the day, which still gives you 2.25 square feet per tile. And then I figure out, based on the floor and what one tile covers, I need this many tiles, right? I don't round yet because I'm not done. Oops. I go divide by 15 because there are 15 tiles in a box, so I need this many boxes, which rounds to 4. And then here's the cost. So let's close that. This is the cost after, and you have to. This is also preparing you for grade 12. If it's dollar amount, you have to have 2 decimals, even if it only shows 0.6 on your calculator. You have to add a 0. If it's square feet, anything else, it doesn't matter. But for dollar amounts, it has to be there. So picky. So picky. This one was, some of you, I think the weekend kind of erases my memory sometimes, but I think 1 or 2 of you got this. Complete, like, get the entire thing. So there's a lot going on here, a lot. So what I did is I found the trapezoid here, I found that angle, and then there's also a pentagon here. Or is it a hexa? 1, 2, 3, 4, 5, 6. Yeah, this is a hexagon here. I saw these. So I subtract, right, the total and 40 to get this one here. So it's a longer process, but then I also find this one here, the highlighted ones are the alternate interior angles, and they're both 40. So you could have applied the strategies I showed you to find inscribed angles, to find those two, and then you get your, and some of you did, I think, something like this, and that's okay. You can always extend lines. That's fine. And I think you tried alternate exterior or something, but if you're not sure why you didn't get the full marks, come and see me, and I will explain that to you. But it ends up being that they are parallel, okay? So that's your Chapter 2 test. Put it somewhere safe